Okay, next thing that we're going to look at is hybridization state and how that affects the pKa of your functional groups. So first thing we're going to look at is, going from a triple bond to a double bond to a single bond, you have different hybridizations. With a triple bond, you're going to have 2 atoms attached to the central atom. With a double bond, you're going to have 3 atoms attached. And with a single bond, you're going to have 4 things attached. In terms of hybridization, easy way to figure out hybridization is that the number of atoms attached is the number of orbitals you need. So if you have a triple bond, that's going to be sp hybridization, 2 orbitals, 2 atoms attached. If you have a double bond, 3 atoms attached, 3 orbitals, so sp2. And then if you have 4 things attached, sp3, 4 orbitals, 4 atoms. Now the general trend involving hybridization is that, the triple bonds are the shortest, whereas the single bonds, these are going to be the longest. As your bond length decreases, the electrons, and when I mention electrons, I mean the electrons that could possibly get protonated or the ones that are holding that acidic proton. The electrons are held closer to the nucleus. If they're held closer to the nucleus, they're going to be stabilized by the positively charged nucleus, and they won't be as available to be protonated. That's point number 2. Consequently, you're going to have a weaker base, so the pKb goes up, and you're going to have a stronger acid. Couple of examples that demonstrate the hybridization state's effect on pKa. Let's take a look at just a sp3 hybridized carbon as compared to an sp2 and then an sp hybridization. If you look at the pKa values, 50, 44, and then 25. Clearly we see that the pKa is dropping down, so you're getting more and more acidic. The reason why you're getting more and more acidic is because these electrons are not as available to grow and grab an H. They're held closer to the nucleus because of the different hybridizations. Of course, these pKa's are really, really high, so you're not going to see any deprotonation realistically at, you're going to see like little to no deprotonation at physiological pH. The more important example to look at is nitrogens. Okay, so here we have an sp3 hybridized nitrogen, and then we have an sp2 hybridized nitrogen in the imine group. Okay, so the pKa of the sp3 hybridized nitrogen is going to be roughly 10 to 11, and then with the imine, it's going to be about 8. Okay, so these are much closer to physiological pH, and you can clearly see that as you go from a single to a double bond, pKa goes down, stronger acid. The reason why is these electrons, as you go from a single to double bond, these electrons are not as readily available to go get protonated. Weaker base, stronger acid. That's why we see this trend involving pKa's.